Alright, in problem number 2, we're going to make a hoop that fits around the sun. And this hoop is made of some sort of incredible material that can withstand the heat of the sun. And but when it's brought near the sun, near the surface of the sun, the hoop expands by 10 meters. Okay? So we're assuming this hoop is circular and that the sun's equator is circular. And so if we take this hoop and we hold it in a position so that it's exactly concentric with the equator of the sun, we're asked to figure out how far above the surface of the sun will the hoop be. Okay? So, alright, so we have this hoop. Let's see. Let's draw a picture here. I need some room though. So let's say this is the sun, kind of circular there. And let's say that this is the hoop. Alright, I'm going to draw it concentric with the sun. Okay, so they both have the same center. And we aren't told what the radius of the sun is, but we'll just call it r. And we want to know how far above the sun's surface the hoop is, so we'll just call that x. Alright. And we don't know how big around, well, we don't know the radius of the sun, so we can't figure out what the circumference of the sun is. All we know is that the hoop expands by 10 meters. Alright, so I'm going to actually define a couple of variables. I'm going to, well, I've already done that actually. I've got r as the radius of the sun, and x is the increase in the radius of the hoop. Okay, so we can say that the circumference of the sun is 2 pi times r. And we can also say that if we take the circumference plus 10 meters, that's now the circumference of the expanded hoop. That is going to be 2 pi, let me erase that, make it nicer. Alright, 2 pi times, again, the radius, but in this case the radius of the hoop is r plus x. So r plus x. Alright. So, what I'm going to do is I'm going to take this and I'm going to substitute, because I know c is equal to this, and I can just substitute it in down here, right? So wherever I say c, I can put 2 pi r. So I can say 2 pi r plus 10 is equal to, and I'm going to distribute this whole 2 pi inside the parentheses. And so that gives me 2 pi r plus 2 pi x. Alright, well, let's combine like terms. I've got a couple of terms that have r, and the interesting thing is that if I subtract 2 pi r from both sides, they go away, right? 2 pi r minus 2 pi r is 0. So I end up getting 10 is equal to 2 pi x. So x has to be equal to 10 over 2 pi, or I can write it as 5 over pi. Alright? And it turns out if you convert this, that's in meters, because everything we did was in meters here. This 10 was in meters, so everything's in meters. But that's equal to about 1.59 meters. And for those of you who don't have as good a conceptual handle on the metric system, that's equal to approximately 5 feet and 2.5 inches. Okay, so that's probably, that might be the height of some of you. Some of you might be able to walk underneath that. So it's interesting. It's interesting, first of all, that the r is canceled. So it doesn't matter what the radius of the sun is. You're going to get that the distance between the sun's surface and the earth is 1.59 meters. And it's also true that if you made a hoop to fit around the earth, and you increased its circumference by 10 meters, it is going to, if you were to put that around the equator of the Earth, then it would be 1.59 meters above the surface of the Earth. And the same with the Moon. If you had a hoop that would fit around that would be 10 meters larger than the circumference of the Moon, and then it would be 1.59 meters above the surface of the Moon. Or a basketball. If you took a basketball and made a hoop that fit it, and then made it 10 meters larger, and then made it concentric with the basketball, then it would be 1.59 meters away from the ball, the surface of the ball. So it's interesting that r doesn't matter. You almost would think that because the circumference of the sun is like 4.4 million kilometers. Okay, I looked that up. All right, so that's about 2.7 million miles. Okay, that's huge. Okay, and it would seem that this 10 meters is pretty insignificant compared to the circumference of the sun, but it turns out that that just a 10-meter increase in the circumference of this hoop gives you 1.59 meters. It makes it 1.59 meters above the surface of the sun. Which is like 5 feet 2.5 inches. So that's kind of interesting. So there you go. The answer is, so it's either 5 over pi meters or 1.59 meters if you used your calculator. So there you go.